Hello and welcome to Space Shark Teaches. I'm Sean, owner and lead developer of Space Shark Studios, and in this series we're going to be teaching Godot. So in this lesson we're going to start getting really complicated with these animations. Like I said in the last lesson, if you want to move on, you can stick with the current animation that we have right now. It just runs really fast. Besides that, it works. We're going to be teaching you how to control this speed by adding some new functions and some new variables. But it is not in any way or shape required to make a functioning game like the rest of these tutorials are. So with that said, let's go ahead and get started. The first thing to do is, like before, we're going to be adding some new variables. So first is going to be animation speed. So this means how many times the animation will happen per second. You can make this an int or a float. Let's make it a float and set it to on. Next, it's going to be cycles per animation frame. So what this means is cycles are physics cycles. So in this case, it's going to be tied to the goal frames per second. You can find that if you go to Project over in the top left, Project Settings, and then scroll down under Physics, Common, you can find the Physics FPS. So for here, we can find it and it says 60. So we are going to make this variable called cycles per animation frame. And that's going to be an int with a 0, and it's not going to be exported. We are going to calculate this using let's say physics FPS. So the same as it's called above or in the properties. Let's just default that to 60, but then set it to export so that we can control it later. And then finally, we're going to be adding cycles since last animation. So this means the number of physics frames that have happened since the last animation frame has happened. Let's go ahead and add that in. Cycles since last animation, let's just say since last animation frame. And once again, that is going to be an int, set it to 0, and do not export it out. So one thing we need to do is set this cycles per animation frame and this cycles since last animation. We don't want to do this every single time. We could definitely calculate it in update animation variable every time, but that seems like a really big waste of resources. Thankfully, function already has a function in this called ready, which gets called when the object is first initialized. So that sounds perfect. So we're trying to say, all right, we want to get or set, we want to set the cycles per animation frame. We are going to use the animation speed, the frames per animation, and the physics FPS in order to get that. So what do we need to do for all of this? Well, animation speed is animations per second, and frames per animation is frames per animation. If we multiply these together, we get frames per second. So let's go ahead and multiply. So this will get us the number of frames that's happening per second. Or animation frames per second. So now that we have the animation frames per second, we can use this physics FPS, which means cycles per second. And so we are going to take cycles per second and we are going to divide it by animation frames per second. Let's go ahead and move this up here. Move all these out of the way. And just to show you what all that does, so right now we have cycles per second. So this right here is FPS, so the physics FPS. And we also have over here frames per second. And so this is going to be animation frames per second. When we divide this, we actually end up flipping this and multiplying by seconds per frame, which gets us cycles per frame, which is what we want. Let's get this S out of there. So let's go back to here by taking physics frames per second right here and dividing it by animation frames per second, which is what this is. We get cycles per animation frame. And that sounds exactly like what we wanted, doesn't it? Move some of this out of the way. So now that we have the number of cycles per animation frame, we need to figure out, using cycles since last animation frame, if we want to move on to the next animation frame. I know this is getting complicated. First off, we should probably change this back to an integer instead of a float. So I'll drag that back in. There we go. So now that we have all of this set up, something that we didn't do before was set up this animation variables. So cycles per animation frame is now set. What we want to do now, though, is say how many cycles since, or has it been since the last animation. We're going to be using cycles per animation frame, and this is going to look very familiar because we've done it once. So we're going to add 1 to cycles since last animation frame, and then we are going to find the remainder. But are we really going to do that? First off, we need to say cycles per animation frame is the cycles since last animation frame greater than or equal to the cycles per animation frame. So this says whichever frame rate frame we're on plus 1, is it greater than or equal to the number of frame rate frames we have waited before we do this whole thing, which we're going to cut and move into here. So if this is true, then we want to go ahead and move to the next frame like we did before. And regardless, I guess not regardless, and if we did, we want to go ahead and set this cycle since last animation to 0. So now, if the cycle since last animation, oh, we forgot one key component here, which is before any of this, we actually need to set cycles since last animation. And then get cycles since last animation. So let's go ahead and move all of this over here. Once I'm done rearranging this, we'll go over it again. So we get the cycles since the last time an animation frame was updated. We add 1 to it because we've gone through one animation cycle, or one physics cycle, and then we set the value. We compare that value to the number of cycles between animation frames, and if it is greater, then we can go ahead and update which animation frame we're on, and then reset this cycles since last animation frame. And that takes care of all of the new variables and all of this commotion that we just added. After all of that, we need to make sure that animate now contains everything. So we can move all of this over to here. So we can call it, and this whole section becomes a lot more clear. So remember, that's one of the key takeaways of a lot of this is, can we make this code more clear? So update the animation variables, and then are we going right? Are we going left? And that is done. So save that off, open up your player, and then check what we have. Physics FPS is 60, that's right. We have 4 frames per animation. Move left starts on 4, move right starts on 0. Animation speed, let's go ahead and set that to 2. And let's make sure that the default for that is 1, because otherwise animations won't happen. That's all still set. And there we go. It was a lot of work, and please let me know in the comments if any of it was unclear. I'm sure there are sections that I could have been more clear, but we now have a full animation controller for our player. As you can see, we can change animation speed now. So it can go as fast as we want them to. We can say only play the first 2 frames of the animation. So he's just kind of kicking it. And if you notice, if we go into one of these and look at these animations, we have speed as well as which frames to play. We basically just recreated this animation sprite. Here's the frame it's on. Is it playing? Which animation is it playing from all of these? All of this should look very familiar because that is what we just made with our player. So feel proud. You just made a very, very complicated system that runs animations in your game. And you can recreate this or duplicate these systems off to things outside of the player character as well if you want to. That's it for this lesson. Thank you for watching, and this has been Sean with Space Shark Teaches.